Why is the solar system considered a parent? Because it has a sun. Alright, what's up, Hive? This is Ron to be the Science Sheet. I got an amazing little series for y'all where I'm basically going to be going over the sun and all the different characteristics. Today, we're starting with the basics of the sun. So we're going to go over what makes up the sun and what are the different layers, what are the different parts of it, and how it was created. So let's get going. So to start us off, the sun is made out of hydrogen and helium. And so what's happening is the sun is like a nuclear fusion reactor. It gathers hydrogen and it fuses it into helium. And it does it in specifically the core. So that's going to be the first layer of the sun that we're going to talk about. So in the core, that is where the fusion happens, is the densest part of the sun, and it's the heart of the sun. This is where all the energy is coming from. Now, next we have the radiative zone. In this zone, this is where waves are getting transferred via radiation, hence why they call it that. But it's also where photons are traveling from the core to the convection zone, which is our next layer. The convection zone, it is what was described in the article I read, kind of like, hot miso soup, where you have layers of heat kind of traveling and bubbling. But this is where heat is again, and energy is again transferred from the radiative zone into a less dense part of the layer of the sun, and now we're into the photosphere. Now, the photosphere is where the science kind of starts, because the photosphere is the last layer of the sun, or it is the deepest layer of the sun that we can actually see using the electromagnetic spectrum, as in radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, gamma ray. Yeah. So photosphere is that last layer that we can see past. We can't see through the photosphere. So we can't see what the core looks like, or the radiative zone, or the convection zone. We can't see the magnetic structure and field lines. So we can't really do a lot of science with that. Now, how do we know that there are those three layers? Well, we use something very interesting. We actually look at the sound waves, the seismic waves that are coming through these different regions, and we're able to tell based off of refraction. When a wave goes through a different medium, it changes, it alters. So based off of that, that's how we can figure out that there's three different layers. Now back to this photosphere, right? Now the photosphere is what we see and what y'all have seen when I do my astro vlogs and I'm looking at the sun. That's what y'all see, just the photosphere. It's a visible light. And in that's where you kind of see the sun is yellow, orangish color, as we all know and love. That's also where you're gonna see the sunspots, which y'all have also seen if you look at my astro vlogs when I look at the sun. The next layer is the chromosphere. Now the chromosphere is right above the photosphere, but this is where more activity happens that's not on the photosphere. And so we get to see a little bit more details of the sun. And on this, I haven't edited this video yet, but you're gonna see a picture where I put up what the chromosphere looks like, what the photosphere looks like. See y'all be on time. So it does look a little different. Lastly, we have the corona. Now the corona is kind of like the outermost level of the sun. And what's very interesting about this is that the corona is hotter than the photosphere. It doesn't make sense, right? Because if this is the outermost layer, it is the farthest away from the core. How is it hotter than the photosphere, which is closer to the core? That's something that scientists are still trying to figure out today. It's still a mystery. There's a lot of mysteries that dwell around the sun. So that's going to be a common thing we're going to talk about. Now, photosphere, I said it's visible light. I'd say that's what we actually see. So yes, when you're looking at the photosphere, you're looking through the visible light part of the electromagnetic spectrum. For the chromosphere, it's a tad bit different. You can look at what is it? The microwave spectrum. You can look like ultraviolet spectrum. You can look at red visible light, because red visible light is also it's pretty weird. But there's specific spectrums. There's specific spectrums that you can look at to look at different parts of the chromosphere, because the chromosphere it's not a big layer, but certain intricacies of that layer, you're able to see different aspects of the magnetic field, because that's where the magnetic field action is going on in the chromosphere. In the corona, since it has a lot of energy, some sources scientists use X-rays to look at the corona. You can also use visible light, but only during a full total eclipse. So I had a video back a while ago where I talked about the different types of eclipse, right? During total eclipse, that is where the moon completely covers the sun perfectly. And so you're able to see this haze around the sun. That is the corona. That's the only time you can see invisible light. So NASA actually has a satellite, I believe it's SOHO. And so it uses a telescope. It uses a camera like LASCO, something like that. But from there, you're able to use, it has like a makeshift eclipse, so that it's able to see the corona using white light. The last way that we see the corona is using radio waves. And that's actually something I have a lot of experience in, because I did some research where I was using radio waves to look at the sun. And that will also be an additional video as part of this series. So the last part I want to talk about is why studying the sun is very important. Studying the sun is very important because it's the only star that we get to see up close, and we're able to do all of our little experiments on, because the sun is a star. And so we're able to make, if we're able to, observations we're able to make about the sun, we can then classify to other groups of stars that have similar size and around the similar age of the sun. So it's very important. For example, we know that all stars have that nuclear fusion, and we know that the nuclear fusion, it creates a force that pushes out, right? That's where we're getting all the energy that's getting pushed out. That's from the nuclear fusion. However, the sun is massive and it has a lot of gravity, right? And it has a lot of mass, because the mass gives it that gravity. So now you have all this mass that is also going inwards. So you have a force of the fusion pushing outwards and the force of gravity pushing inwards. That force is balanced when the star is alive. But when the fusion is at its limit, when there's no longer any more hydrogen to turn to helium, then that's when the force of gravity, the force of the mass, now overtakes it, and then, you know, the star dies. We start getting to supernovas, we start getting to white dwarfs and all that other, you know what I'm saying, astrophysics. But that's something we learned from studying the sun, and from there, that's how we're able to deduce that about other stars. So very important stuff. Well then, I'm gonna end the video off here. This is gonna be the first part of the series. Until next time, if you liked the video, don't forget to give it a like, go and subscribe. We're on to Be the Science Sheet. If you didn't like the video, give it a like and go and subscribe. I'll see y'all later.